Hello guys, and welcome to this video to learn how to do your own bite splint, okay, so an occlusal splint with CAD-CAM, okay, so using a milling machine like this one. This is the M1 from Zirconzan, and we are going to be using this one today in this procedure, okay. So you guys are seeing on the screen that we have an intraoral scan, and basically that's the method that you need to do your digital or CAD-CAM bite splint. Okay, so I'm going to how to obtain this image, and of course I'm going to go back one picture to show to you guys that that's basically the procedure, the intraoral scans, right? You basically need 4 intraoral scans. We already commented about intraoral scanning techniques in previous videos, including the one of detecting caries using the intraoral scanner. I'm going to add the link here on the top right corner of this screen. And basically you need 4 intraoral scans. So you need the upper, the lower, and then the bite registration, which could be 1 or 2 scans, okay, depending on the case and depending on the system that you are using. That's the trios from 3Shape, but the trios 5, but of course it depends, okay? So that was actually the trios 4, but I used the trios 5 in this procedure. Okay, so why this intraoral scan has colors now? Because it's actually a PLY file instead of the conventional STL file. If you guys don't remember what are those files, go back to my video about virtual patients, okay? And then you guys will be updated to enjoy this video a little bit better. All right, so now the intraoral scans are imported here to the Modelier software. And before, I'd like to show to you guys that you can also integrate your intraoral scans with CBCT, for example, like in this case, and then the mesh. I will now show to you guys that we have the mesh, okay, of the intraoral scans here. So basically that's intraoral scans, okay, that's why we see the gingival tissue all over here. And the mesh of the intraoral scans now in this image has those dots, pink dots, right? But then all the rest, we can even see the interface here, all the rest is the bone from the CBCT scan, of course. Okay, so basically everything else here is the bone from the CBCT scan. Okay, so of course that depends. You only have CBCT if bone information is needed, so for surgical planning and those things. That's not really the case of today. You don't need a CBCT to do occlusal splints or bite splints. All right, so let's go back here now, and let's go back to our procedure. So basically we imported the intraoral scans to the CAD software, to the design software, and here we have the Zirconzan Modelier, of course. And again, you don't need the CBCT. You could have the CBCT integrated, but here we are now mounting the virtual articulator, right? And you guys are seeing this distance here, which is very important, okay? That's the distance of 90 millimeters, all right, from the cusp of the first molar, the upper first molar, to the center of the rotation, to the back of the virtual articulator. So there are several theories accepted in the literature. That's basically one of them. And the Zirconzan articulator has the center of rotation in the mastoid process, which is always fixed, instead of the condyle, for example, the TMJ, right? So this is considered as an advantage, but there are again several guidelines described in the literature to do that. All right, so let's move forward now to see the occlusal plane. So then, of course, we have occlusal plane. We can use a digital face bow. We can use we can input measurements manually. There are a lot of ways to do this. Okay. This would be basically an entire lecture of 4 hours, for example, about virtual articulators. But the thing is that you need to have your intraoral scans positioned in the occlusal plane, okay? So basically that's the occlusal plane, and then this will allow you, of course, now the mandible of the CBCT is no longer aligned because the CBCT was taken with an open bite or not biting. But all we want is to mount in the virtual articulator here, right? So you basically need only the intraoral scans. All right, so you have your occlusal plane, and then those are the measurements. So now we have basically 90 millimeters from the first molar to the center of the rotation of the virtual articulator, and then positioning the midline and on the occlusal plane that we have there, right? So we have that automated occlusal plane, and we are using this plane actually to do to mount the virtual articulators in occlusion. All right, so that's just a lateral view of the same thing that I was telling to you guys now. And now we have the virtual articulator only with the intraoral scans, exactly what you need to do here. And then we have this extrusion of the intraoral scan. You can even make a dental cast, for example, but that's the bite splint. So the bite splint is here now, okay? So let me give a zoom now, and basically that's the bite splint, okay? So the bite splint is here. So that's the bite splint, okay, the gray one, okay, between the lower and the upper arch, okay, so that's the contour of my bite splint, okay, so this is my bite splint, okay, protecting of course the occlusion. That's the purpose of an occlusal splint, right? So to protect the teeth, to avoid the bruxism alterations. There are different materials and different types of occlusal splints, so that's not the purpose of this video on differentiating all of them. One of them is the Michigan one, that we have a flat surface where the patient will bite, allowing the mandible to be free to do lateral excursion and protrusion, okay? That's basically the purpose of this occlusal splint in this case, and that's the one we are trying to do here, using a very small thickness of material, okay? So the design is also a design that we do in the CAD software. Of course, we need to avoid undercuts here, and we want to make sure that this will fit properly, right? Well, let's move forward. Then after the design is ready, we need to nest this bite splint or this occlusal splint. And basically that's the material that we are using here, okay? So that's a disc of PMMA, transparent PMMA. This could be 3D printed as well, but we are using a very nice material from Zirconzan. So that's the material. So we have here a transparent PMMA, very nice flat and clean material here, all right? So the transparent PMMA for bite splint. So you could do also 3D printed, but the patients are actually, according to our experience, reporting a better comfort using the milled ones. All right, so we have here the nesting procedure. You need to add those supports, okay? So there are a lot of guidelines, but just to show you the general procedure, how it's done. So we have those supports here on red color, all right? And you need to make sure that this will be stable enough to avoid disturbing the milling procedure, okay? So you selected your disc in your software. There is even a QR code for you to scan, and then the correct material will be recognized by the software. And then you just input this material on this, you just import the virtual disc, and then you nest three-dimensionally your object, so in this case the occlusal splint, on the disc to make sure that all the dimensions of the disc are included by the dimensions of the disc. All right, and then all we have to do is to mill using this milling machine. So that's basically a picture of the procedure. So during the milling of this disc, okay, so we are milling the bite splints, all right? Then the software will tell you what are the correct burrs and everything. So it's a very easygoing and straightforward software. The entire digital workflow of the Zirconzan system is basically like that, very straightforward. And that's your bite splint ready. Okay, so now you need to cut off the supports, of course, and then it's basically ready. Of course, you could polish or something, but it's usually very nice already. And that's the bite splint in position, and look, lateral excursion from both sides, confirming the canine guidance. That's very nice. And now the incisive guidance, okay, being confirmed, disoccluding all the posterior teeth. Okay, so there was a little bit of saliva there, but actually all posterior teeth were not in occlusion when protrusion was performed. Okay, so basically that's the final result of a very thin bite splint. I am actually testing here a very thin design, and it never broke, so it's actually working very nicely. All right, So that's the general steps of the procedure, but I will also add some links of CAD-CAM theories here in case you guys want to look into this in more details. All right, so if you guys like, please hit the like button and see you guys on the next video.